Hello and good morning to everyone. Nagarjuna from Surya HANA Academy. So, hope my voice is clear and audible. Please, any of you, could you please confirm to me? Thank you. Thank you so much. So, in today's session, first I would like to recap yesterday's session, and then we'll start the practical, what we have seen, theory about what is a column table, what are different types of delta merge, what is dictionary compression, how we can see compression ratio inside HANA table. All we will see in the practical. First, yesterday we discussed about when we see visualization plan, we have something called search on a table. When it does search on a table, it search both delta area as well as the main area. Delta area is optimized for insert of data, whereas main is optimized for reads of data. A table in HANA, a column table in HANA, is divided into two parts, main and delta. Whenever we insert data available in delta, from delta the data is moved to main. The process of moving data is known as delta merge. So what is delta merge? Delta merge is the process of moving data from delta area to main area. Now why system has to move data from delta area to main area? In delta areas data is uncompressed. In main data is compressed. Once the data is compressed, the data is available in the form of integers. System converts strings to integers, known as encoding of data. When it encodes data, it uses special algorithms like run length encoding, where it can compress data very effectively. For any redundant values stored in a column, system maintains a dictionary for it. It assigns unique value for every dictionary value. Instead of storing strings in the table, it stores integers. So wherever it sees the value, it replaces with the unique value that is stored in the dictionary. If the data is encoded and kept in the table, now when user is trying to query, it reads from both the areas. When user tries to query, it reads from both the areas. Uncompressed data, it reads from delta area. Compressed data, it reads from main area. The only difference we find is when it reads uncompressed data, because data is in raw format, it takes time to process the data. When data is compressed, it does on the fly decoding of data in the L3 cache memory of the CPU. By using massive parallel programming techniques, it's very effective to decompress data on the fly when the user executes a query. So when the query is executed, it gets data from both the areas, from delta as well as main. There is a process called hot dog. Hot dog is a process that keeps monitoring when to perform delta merge. Delta merge is of three types: hard merge, auto, or soft, hard, and smart. Hard, auto, or soft, smart. Hard. User perform manual delta merge. Right click on the table, perform delta merge. This is hard. System automatically performs auto, or also known as soft. When will system perform? There is a criteria. Whenever we get 1 GB of incoming data, immediately system perform delta merge. Or whenever the system resources are free. For example, usually in the morning from 10 a.m. till 8 p.m. my business hours. So during the time, system is very busy inserting data into these tables. At the same time, users are also very busy inserting and reading data from these tables. When the system is busy writing data and reading data, most of the time system avoid performing delta merge because the priority is given to reads and writes of data. Let's say the next day is a public holiday, for example, and business is not there is no operation much load on the system. So during this time, what system does is it utilizes system resources to perform delta merge. So it depends on what is the load on the system. Whether the system is extremely busy. Now, how does system know? It depends on utilization of the system. How much CPU, how much disk, or how much memory is utilized. Based on this utilization, system performs the delta merge. So auto is performed based on two criteria. One is when you have more than 1 GB incoming data in the delta, immediately it performs auto. The second reason is based on the system resource availability, it performs auto. Most of the time, if you see, from night 1 a.m. till morning 5 a.m., most of the business is not conducted. So during this time, system utilizes its resources to perform delta merge. And the last one is smart. Smart is executed at the BW application layer. In the ABAP application layer, we have jobs that are running. So these jobs are known as DTP, data transfer process, the process to transfer data. These are basically jobs. These jobs, when they run, it executes smart merge. They trigger database, they trigger delta merge at the application layer. Smart is triggered, excuse me. Smart is triggered at the application layer. Auto, more than 1 GB of data incoming based on the system utilization. Hard merge, manual execution of the delta merge. These are the three types of delta merge that you can see in the configuration of the HANA database. So first, I'll just try to show you how a delta merge is performed. Then immediately we can see the other options that are available in the column table. Hello, is my voice clear? I see some messages that my voice is not clear. I just saw some messages. Is this okay now? Uh, Also, my advice to everyone, just one small advice to everyone. You see, these are the users that are running in the background. You see, these are the users that are running in the background. You see, some users are active. Means it means that some users are working on the system, and you see, other users are actually they're not working, but still their processor, still their work is running in the background. So my advice, please kindly disconnect. Just you need to just do something called start. When you complete the work, please log off. Just click on log off. What happens is, because of this, the other users may experience performance issues. So if you see the utilization of the system now, it the CPU percentage is going around 90%, and then the memory is 31 GB because the users are not being disconnected. So please kindly, whenever you have completed the work, please kindly disconnect the. Just what you have to do is start, log off. Once you log off, click yes. Automatically disconnect. So when you log in again, connect. Or what I have to do is I have to go manually. Every time we have to disconnect this manually. So just I have to go and select log off. And this only can be done in the administrative account. So you have to do a manual deletion of this because users are disconnected, they're not using the system. Now once I delete all these which are not active, now we see system performance is now 27 GB, and it will decrease slowly, it will try to decrease the utilization of the system. Okay, so first we log into HANA Studio. Now let us expand catalog. Let us go to best schema. Under best, let us expand tables. I'll go to KNA1 table. So we are at the KNA1 table. Now if I double click on the table, click on runtime information, Now, on the columns of this table, already the compression has been executed. So when I say the data is written into delta storage, so let me show you one of the data provisioning method. This is only I'm showing just to get data into one of the tables, but we'll see in detail when we start data provisioning topics. So I'll click Start, All Program, and then I'll go to Data Services 4.2. I'll go to the workbench. So this is one of the data provisioning method. I'll give the username and password. Password is wcapitalwelcome123. I'll expand system, expand the catalog, go to the schema best. So when is this table created? Let us see K1 table when this table is created. This table is created on March of 24th. On the March of 24th, this table is created. Now I'm recreating this table. So right click on the project, new, click on replication job. We'll revisit again to this exercise. We'll go in detail. But for now, I just want to recreate K1 table. Just to show you the concept of delta merge. So I'm creating a new replication job. Under this replication job, I imported few tables from ECC. So I'll take one table called K1. I'll drag and drop this table into the replication job. Replication job is a job that initiates the data transfer from ECC to HANA. So I'll select this replication job, target data store. I'll click on this, select HANA, click validation successful. I'll execute the job and click yes. So this is the job server. I'll select the job server. I'll click finish. Now it is transferring table and its contents from ECC to HANA. So it will drop the existing table. It recreates a new table and loads the entries into the table. The job is running. So it's trying to load data into HANA from ECC. Job is successful. So I'll go back to the table. I'll refresh the table. I'll just click refresh. Now once I refresh, now here you see when data is loaded to HANA, when data is loaded to HANA, the first time it loads data to delta storage. In the delta storage, the size of delta is 11,041 KB, approximately 11 MB of data approximately. This is the time of creation, March 29th. and this is the number of rows. Now, when I right click on the table, and click perform delta merge. I click perform delta merge. This action merges the committed entries from the table's delta storage into its main storage. Are you sure you want to perform delta merge operation for the table Kenya1? Click OK. Once I click OK and refresh, now 11 MB of data is now compressed to 4.4 MB of data. Approximately more than 50% compression has been executed. Previously it was 11 MB, now it is 4 MB. But how the data we see is same. Now data from delta storage is moved to main storage. So when I right click on the table, open data preview, how we see data is not changed. Before delta merge and after delta merge, it is same. There is no difference in how we see data, because when I right click and open definition, click on columns, let us take one column like land 1. So land 1, the total size is 14 KB. Main size is 4, whereas delta size is 10. This 10 is nothing but the default allocation. A default allocates for incoming data. For example, any incoming data may come, it will basically allocate 10 KB. Its space allocates for the incoming data, the new incoming data. And this is the existing data. And the total compression executed on this column is 22% based on how many distinct values it has. Now if you see one of these columns called KUNNR, now KUNNR is customer ID. So how many distinct records it has? It has 19,575. 19,575 distinct records are there. How many records are there? Same. So there is no compression executed at all. Now why? Because every value is unique, because this is a primary key. In that case, the compression executes is less, and so the compression ratio is 77% here, because there is no much compression. Loaded. Now it is taking the ratio. It is taking the ratio of the percentage on the compression. This column called loaded. Loaded is a column where it will specify whether the data is in memory or is in disk. Now what is the use of loaded? For example, when I click on the table, open data preview, if I click on distinct values, if I click on land 1, only for US region we have around 14,000 rows that are existing in this table. And then you have Germany, we have Great Britain, and so on. For example, most of my business users are from US, for example. And this is the only data they report on. Or I'll take one more example. There's a column called year. Most of the business users try to report on the current year, last year, for some till some extent. Now, let's take 5 years back, the year of 2010. Most of the business doesn't execute 2010 because the data seems to be outdated now. So what HANA does intelligently is, for data that is not being used by the system, for a column like year, when you have data that belongs to different years like 2016, 2015, 2014, 2010, this data is not being used by system. So system knows based on the selection on the data. From 2010, the business is not using frequently. So it offloads to disk. So in HANA, we use SSD, solid state drives. And on top of SSD, we have memory. So all the hot data is kept on RAM. The data that is not being used frequently by the system is offloaded to disk. Again, this is a technique to save memory space. Whatever the data that is not used by system or not frequently being used for reporting, it basically goes to the SSD. Managing of this data, what data to offload and what data to keep it on memory, is taken care by system. Now, if I go to HANA, right click on this table, here you see an option called load into memory and unload from memory. Now, when I open the definition of the table, please see the total memory consumption now is 4.4 MB of data. Previously it was 11. After compression, it has become 4.4 MB. Now, when I right click on the table and click unload from memory, and I click unload from memory, this action unloads the table, including the delta storage from memory. The next time the table is accessed, it will be slower because the data will have to be reloaded into memory first. Depending on the size of the table, unloading it from memory may take some time. Are you sure you want to unload the table K1 from memory? So this is nothing but, let's for example, in any case, usually in a data center where the HANA is kept, now we know when a power is lost, even even for a simple house, we have UPS. Even for the normal household activities, we use UPS. Now think about data centers when they have IT computers which are 24/7 running. They have very powerful UPS which never allow the system to shut down unless and until we do it. Now, for example, there is a long power shutdown. For example, there are 10 days of power shutdown due to some reason. Obviously, the UPS is not sufficient to take care of the systems. So, the power is shut down, for example. So, when the power is shut down, we know the property of memory. It's volatile. Whenever the power is shut down, the data from entire memory is lost. If the data from memory is lost, now where will data reside on the disk? Why? Because any insert that we perform into the memory, at the same time, there is another set of record that performs in SSD. So when you insert, there are two things happening at the same time. One, data is returned to the memory, and data is also returned to the solid state drives. Here is the permanent storage of data, and here it is temporary storage. I mean, it writes data here, but when the power is lost, because memory is volatile, the data is lost. That's why we keep backup of data in SSD. So now, when a business user query, always it picks data from memory, not from the disk. If the particular set of data is not available in memory, then the request is sent to the disk. It picks the required data and then uploads to memory, from memory to the front end. So that is the thing that it says here. The action unloads tables including delta storage from memory, because this we are doing manually. If the power shutdowns, it will offload from memory. The next time the table is accessed in any query, it will be slower because the data have to be reloaded into memory first, from where it has to reload from SSD. Depending on the size of the table, unloading it from memory may take some time. So for now, what we're trying to do, we are unloading. So how much data we have? 4.4 MB. When I click OK, when I click OK, click refresh, the total memory consumption is 0. It means that the main storage is 0 and delta storage is 0. Now there's no compression, loaded is false. So there is no data in memory. The entire data from memory for that particular table is lost. Now, when I lose the table, when I lose the contents on the table, I can basically do two things. One is I can right click on the table, load into memory. When I hit load into memory, this action loads the complete table, including the delta storage into memory. Depending on the size of the table, it may take some time. Are you sure you want to load the table into memory? Click OK. Now this is what happens when the power comes again. Slowly, the data from SSD is loaded back to memory. Because it cannot load, now for example, you have 5 terabyte of data in memory. Let's say example, excuse me. When we have 5 terabyte of data in memory, the same 5 terabyte of data is in disk, for example. Now when the power is lost, I cannot get this 5 terabyte into memory, because SSDs are not so fast as memory to load the entire 5 terabyte once the power is on. I cannot get this entire 5 terabyte. Slowly the system loads data. From here, at the speed at which it can process data, it can slowly load data into this. The slowly loading of data is known as lazy loading. Lazy loading. When the power is on, the system cannot get all the tables into memory. So it gets high priority tables. Now what are high priority tables? How system know a table is a high priority? Now, first of all, when the power is up, it loads system tables, because the database have to get up. The database have to get up. So all the system tables that are important to HANA is loaded into memory first. Once the system tables are loaded, if the business indicates to the IT team that these are some of the important tables that needs to be immediately available once the database is up. There are some important data that business always requires on the first hand. So in the configuration, HANA administrator checks those tables. Once the system is up, these tables are loaded into memory. So first, it gives priority to those tables to be loaded into memory automatically. And then the other tables, which are not frequently used tables, not priority tables, system does slowly into memory. This is known as lazy loading. So when I actually click OK now, so what are we trying to do? The table is empty. I'm trying to load again to memory. When I click OK, click refresh. Now this time, now you see there is approximately 3049. It means that data is not fully available. It's only partial availability of data. Data is available, but partial availability of data in memory. Because as we discussed a concept called lazy loading. So it slowly keep loading data, but whatever the data that I frequently accessed, that will be available in memory. So this is one way I can do right click and load into memory. But there are millions of tables I cannot do for every table. It's really impossible to do. But just to show you, we have an option I'm showing you here. We can still load into memory by using this option. But what system does is, I'll do unload from memory again, click OK, click refresh. Now data is deleted again. When I right click on the table, when a business is trying to view data or contents from the table, click data preview. Now please see how much time it has taken. It has taken 437 milliseconds. Now why it has taken so much time? Usually it takes around 30 to 100 milliseconds. It has taken a lot of time. The reason is data is available in SSD. When I want to data preview, I select to memory, it doesn't see data over here. Then it goes to disk, fetch, and keep it in memory. So now when I go back, now when I refresh for the second time, when I refresh or when I right click and data preview again for the second time, it takes around 109 milliseconds. Now when I refresh again, when I data preview again, it takes 31 milliseconds. So usually it varies from 30 to 100 milliseconds for a table that I see most of the time. But for the first time, it has taken 4 times, that is 400 plus milliseconds. The only reason is when you access data that is not in memory, when it is on SSD, only for the first time, when I data preview, it will go to the SSD, fetch data, again back to the memory and to the front end. That's why it has taken 400 milliseconds. When the data is available in memory, when I see it takes only 30 milliseconds to 100 milliseconds. So this is known as loading and unloading of data. So let me open the table definition again. Open definition. Click refresh. So here you can see each table size, main size, delta size, compression ratio, and then record count, distinct records in each column, whether the table is available in memory or not. Also, when you right click on the free space here, you have something called configure table. When you click on configure table, so you also have one more column over here, which is known as compression type. So when you select this compression type, click apply and click OK. So internally, system uses different compression methods. So when I go to the site, you have different algorithms that system executes internally in the kernel of HANA, in the heart of HANA. So the kernel of HANA, the entire kernel of HANA is written in C++ language. You know C++ language, and the system for now supports two operating systems. One is SUSE Linux and the other one is Red Hat Linux. At the kernel of HANA, the algorithms executed internally. The different algorithm types you have: default, RLE, run length encoding, SPA, RSE, indirect. For every column, it uses prefixed. These are the different algorithms. For every column, it has a different algorithm type the system executes internally. And these algorithms are executed at the heart of HANA. And the decompression, now it's only showing the compression. And decompression, when right click on the table, open data preview. When I see the data preview at that point of time, it executes at the L3 cache memory of the CPU. Now, when I right click on a table again, when I perform delta merge and click OK, right click on the table again, open definition, click refresh. Now, what type of delta merge I executed? I executed a hard merge. So I can see the what kind of merge I have executed. I'll go to the top, double click on the system, double click on the system, click configuration, click configuration. I'm sorry, click on system information, not configuration. Click on system information, expand system folder. In here you can see there is a property called, yeah, this is the property. There is a property called merge statistics. So when I double click on this merge statistics, so here you see I executed a delta merge. So here you see on the KNA1, and the KNA1 table, I think this is the first time, second time I deleted and reloaded the table again. So I executed a hard merge. So you have different types of merge. When I execute manually, that is a hard merge. When system executes, it's auto. It's auto merge. System executes the merge. The last time executed is hard merge. The last I right click and execute. And then also we can find another merge which is, I'll just type in smart in the find. I think there are no operations on the BW system for now. That's why we don't see smart merge. So smart merge is available. I'll just show you the option. We go to SAP logon. Let's go to BW on HANA, BW powered by HANA. Let's provide the username and password. So we'll discuss these options again, but just want to show you where the smart merge is executed. I'll show you that option where in the application layer, the ABAP application layer sends request to HANA to execute a smart merge. So meanwhile, I'll just try to recap. So we were seeing how to load data into memory. Unloading is nothing but deleting data from memory, and load is reloading from SSD back to memory. Either you can right click and unload, or you can right click. Once you data preview, the data from memory is loaded back to, sorry, the data from disk is loaded back to memory. Delta merge is a process of moving data from delta area to main area. When we move, compression is executed. You can see for each column how much compression is executed by right click on the table, open definition. Also, you can see different types of algorithms that system internally executes. At the right click, open definition, you have compression type. For each column, it executes different compression type on the type of data that it has. You can see compression ratio, how much size it has on delta, how much size it has on main, what is the total size both in delta and main. So when you have distinct values, the compression ratio is high. When you have redundant values, the compression ratio is low. We can see different types of delta merge. You can go to system, you can go to system information. There you can see merge statistics. So now I'm just trying to show you on the DTP. So this is the job. This is data transfer process. So when we go to this DTP, when we go to this DTP, when I right click and create DTP, data transfer process, click continue. So in the update tab of the DTP, here you have trigger database merge. So when I activate this job, this is known as the DTP, to transfer data within BW. We use this option. When I actually execute now, this I'll simply execute this because I'm not sure that whether we have data or not. Just I'll execute this DTP. This all things that I'm discussing now, we won't be doing because we will not have an opportunity to do this, but just we need to understand what is a column table, which is a new concept. But when we're working in real world, we will not do all this part because this is purely taken care by admin. What type maintenance of tables, and whether any delta merge getting failed, all these activities are not part of our job. This is the part of the HANA administrator. Only for good to know, and only for knowledge we are discussing this. But when we work on the job, we will not have an opportunity to work. Just to good to know what is a column table, what is delta merge, how the column table works internally. We are seeing all these things. As a modeler, we won't be performing these activities. So I just executed this database merge. Now if I go back to HANA, when I click refresh, let us find whether the merge is executed. Still not. So there is some error over here. Anyways, we'll discuss later about this DTP. So this is the option in the DTP when you have successfully executed of the DTP, triggering database merge allows us to see a smart merge inside the HANA tables. So these tables that I'm showing you here, when you double click on any of these tables, click on information, click on dictionary DB status. Now you see there are different tables over here in the ABAP layer. So when I copy any of this table, when I copy this table, I'll click on systems, click status. Now here you see the application layer is on the database which is HDB. The owner is nothing but the name of the schema. The schema is SAP ABAP 1. So if I go back to HANA, if I go to SAP ABAP 1 schema, I expand the schema, expand the tables, right click on the table, filters, copy paste the table that we got from BW, click on whole word, click OK, and here you see the table from BW, right click, open definition, click on runtime information. So on these tables, the system will perform smart merge. So when it triggers the database merge, then on these tables it performs the smart merge. But smart merge is not executed. The DTP is failed. These are the tables it executes smart merge on the BW tables. Okay, now let me try to recap. So table, two parts, delta, main, delta, you move data from delta to main, data merges of three types. One is hard, manual, soft, system performs, and third one is smart, executed at the BW application layer via DTP. Soft or auto, you can see in the merge statistics. So when is auto or soft perform? 1 GB, more than 1 GB of incoming data based on the system resource availability. Hard, manual execution of this. Whenever we try to read data, it reads from both delta area as well as main area. When data is moved from delta area to main area, delta merge is executed. The moving of this data is taken care by hot dog. There is a process that is running in the background called hot dog. So hot dog is a background process that monitors to take care of the delta merge. Most of the time, there is at least 50% reduction of less than 50%, but most of the time 50% of the database merge is, compression is executed. 1 terabyte of data you have, it varies from 250 GB till 500 GB, the data is compressed. You can unload from memory and you can load back into memory. It depends on how frequently you use data from these tables. System automatically performs loading and unloading of data based on the frequency of access data from these tables. Now, let us see the difference between a column table and a row table. Now, do we have all these features in row-based tables as well? Let us go back to HANA Studio. We will check one of the row-based table. We'll check one of the row-based table. So all these are column tables. I'll go to the best schema. Expand the best schema. So this is a row-based table. You see, this is the symbol for row-based. When I double click on a row-oriented table, this is the row store. When I click on runtime information, please see, for a row-based, we don't have delta or main. We don't have delta or main area. But still, row-based tables store data in memory. Row-based tables store data in memory, whereas column also stores in memory. Row stores are different, column stores are different. Column stores are optimized for writing of data. Sorry, column stores are optimized for reading of data, and row stores are optimized for writes of data. But both column and row stores data in memory. Both the stores, row store and column stores data in memory. But row doesn't have main area or delta area. So when to use row and when to use column? You see, here you check all these row stores are system tables. All these tables that we see here, all the tables that are created over here are system tables. So for a system table, usually for system to maintain data, do we read data from system tables or mostly we try to store data? So most of the time we use a row to store. We rarely read data from row stores or we rarely use system related information. Most of the time the data which is read, which is optimized to read, we keep it in column stores. Why we keep it in column stores is because the column tables, you have lot of columns. When you have lot of columns, you want to read only few columns. You have a table with 200 columns. We only want to read 4 or 10 columns or 20 columns. Then we store in column store. When you read, it only hits those 4 or 10. But if you see in row oriented table, you see most of these row tables, you see there are 4 columns, 3 columns, 1 column. Any row table that you take here, 18 columns, 9 columns. 12 columns. But if I take these business tables, KNA1 table, 194 columns, LIKP, 179 columns. TC, the tables which I store business, CE1, 226 columns, MARA, 223 columns. So when to store in row, when to store in column. So row-oriented tables are good for single selects. They're good for single select. Single select means one row but all the columns. Or when you do a select all, right click, open data preview. You're trying to read the entire table. Select all. They're good for select all. You're reading the entire contents of the table at once. Or you're doing a single select. But column tables are good for set processing. Column tables are good for set processing. When I say set processing, what does that mean? Set processing in the sense, I'll take only land 1. I'll take land 1, only one record, say one column. But I'm trying to read entire data from this column. Few columns, but all the data in the columns. For example, C1 IDA, column table. I'll take BUKRS, VV010. I'm seeing, based on company code, I'm seeing my gross revenue. Column stores are good for this. But in C1 table, how many columns I have? I have more than 226 columns. But how many columns am I doing reporting on? Only 2 columns, BUKRS and VV010. But I'm trying to read the entire data of BUKRS and entire data of VV010. Or I'll take a few more columns like VKORG, KNDNR, VKORG, KNDNR. Again, in here I'm only trying to read 3 columns, 3 plus 1, 4 columns. But I'm trying to read the entire data from these columns. So column stores are good for few columns, all the data from columns. Set processing, you're trying to process set of records, but the number of columns are few. This is good for analytical purpose. But when you try to read on a row-oriented table, either it is good for reading the entire table or a single record in a table. A single record in the table means I want to display net value of the sales document on a particular order. Only for one order, I want to see the entire row. If a table consists of 200 columns, I want to see the details of the entire order information only for that particular row. One single row, all columns. Row orientation is good. And the other case is few columns, all the data in the columns. Column stores are good. I also want to give one more example here. Column stores, as we discussed, they're good for reads of data. Now, which is good for reads of data, where main is good or delta is good? Main is good for reads of data. But I'm discussing delta is good for writing of data, because data is not compressed. Because When you write data at the same point of time, if system does compression, if the system is executing these algorithms, it may delay writing in data because it has to do two operations at the same time. That's why we store in a temporary buffer called delta and then we move into main. When we move into main, data is compressed. When data is compressed, we can load faster to the front end. Now, now even the delta store is optimized for writing, but not so effective. But not so effective when coming to writes of data. For example, we get data from sensors. When you're getting data from sensors, the data continuously keeps streaming. For every second, there is a lot of changes on the temperature. For example, we have a sensor which can gauge temperature on a particular engine. For example, there is a sensor inside the car engine. That sensor should gauge the temperature of an engine. So the temperature keeps on changing. So it has to keep sending that information to us. So in this case, you get so many records from so many sensors, and it has to write in a single table. And even in such a case, delta is not optimized to take high speed inserts. To take care of high speed inserts, delta is not optimized. And then system temporarily creates something called L1 delta. Again, in column stores, there is an area which is acting like a row store, which acts like a row store. A temporary buffer is created for high speed inserts. How a row store can take inserts very faster, even a column store can take inserts very faster. When you actually have writing of data, because HANA can support Internet of Things, means I'll give a simple example. We know there is this car race going on, F1 racing. So each F1 car have more than 300 sensors. Each car of F1, when they go to race, this each car has 300 sensors. So each sensor will continuously stream data. What is the pressure in the tire? What is the heat that engine produce? So for each and every device, they have sensors. These cars are very, very expensive. When the race is going on, the sensors continuously stream data. There is a backend team which continuously monitor the health of the car. We may not know when the car may blast, and when the blast occurs, there is a disaster. It threatens life for the driver. So, in order to avoid such a situation, in order to avoid the heavy loss, HANA can help us to analyze a real-time streaming of data. It streams data in real time. When the car is on race, it streams continuously, keep sending. When any of these threshold values are met, there are threshold values, there are business rules written in the back end. When the threshold values are coming to near, there is a threat to the car. Immediately, the back-end IT team who continuously monitors this real-time information, and that too in HANA, which can process data instantly in a very efficient way. It can save the car as well as, most importantly, the human life of a driver in continuously analyzing this data. So, when SAP in the initial version, then they released HANA, they don't have this L1 delta. But later, from SP 7 onwards, they introduced when it starts supporting LOT, Internet of Things, to get data from sensors. Then where it needs high-speed inserts and high-speed reads. So there is another buffer area called L1 delta, in where you can write data into this temporary buffers, and then from these temporary buffers You can again send to delta and from delta to main, and where it can read data at these three areas. When you fire a query or when you do a real-time data analysis, you can read data from these areas at the same time. At the same time you can read. At later stage, the hot dog merge data from delta to main area. So even in a column store, there is a temporary buffer called row store, which is used for high-speed inserts, which is known as L1 delta, especially for sensor-related data. So simply to conclude this topic, row stores are optimized for a select all or single selects. Column stores are optimized for set processing. Few columns, all the records from columns. When you have high-speed insert, column store creates a temporary buffer area called L1 delta, where it is used to write data, and from there it writes to delta and main. When you read data, it reads from all these three areas. That's for today's session. If you have any questions, please ask your question. I will read out the question and try to answer your question. Thank you. So I'll read out the questions here. So the questions here. Who does hard merge in the production system? This is the admin who does the hard merge in the production system. We will not be able to perform hard merge. The admin who does. Is admin or the application developer who does hard merge? Admin does. Main area is on disk or in memory. It depends on whether the data is on disk or memory. If it is on RAM, the main area is on RAM. Even the main area can be offloaded to disk. When we use DXC, DXC is a data provisioning method that is used to transfer data when we have BW system on the sidecar scenario. We use DTP for moving data of BW to HANA. Then what is the importance of DXC? DTP is not used to move data to HANA, but it's used to move data within BW. DXC is a data provisioning method that uses HTTP protocol to transfer data from BW to HANA. We'll see this as a part of data provisioning method. We'll see more details into it when we discuss. But now, DXC is a method of data provisioning. We can move data that usually goes to BW. I can now bypass the data from BW to HANA. To move data from disk to memory, we use data provisioning method. How does system do frequent unloading and loading of data between memory and disk without using data provisioning method? I think there's little confusion. I'll try to clear the confusion. So data provisioning is different altogether, and delta merge is different. Delta merge is executed within a table. Delta merge is executed within a table. Or unloading and loading of data is executed within a table. All the options that I discussed today's class is happening within a table. When we talk about data provisioning, we talk about two different systems. Means we have two copies of tables. One copy of the table in the source system and the other copy of table in the target system. So when we talk about data provisioning, we move data from one table to a different table in two different systems. But once the data is available in table, the delta merge, main area, delta area, unloading, loading, all the options. Now I'm referring to a table which is a column store, and the table is in HANA system. Let us see the next questions. In what scenario do I have to use delta merge in real time? Delta merge in real time, to tell you very frankly, we don't have control of delta merge. System decides when to merge based on the system resource availability. So for example, in our business, we introduce a new offer today, 50% off on our products, for example. Now system is so busy to take incoming orders and processing these orders. Now during this time, system never perform delta merge because system is very busy in receiving data. High priority is given to receive data because it has to take orders. So most of the system resources are allocated to perform that. Now let's say on a particular day there is a holiday. Now during that time, because the system is not so busy, it utilizes system resources to perform delta merge. So high priority is given to operational procedures, and system takes low priority to do delta merge. But in any case, whenever you try to do analysis, it actually doesn't matter to system because it can read from both the areas. Whether the data is available in main area or a delta area, when you fire a query, it can read from both the areas. It means we can read data at any point of time. But only thing is the data is not so fast. That also it's very minimum. It's very minimum, but still it helps to save space on the memory. So what is the main purpose of delta merge is? The main purpose of delta merge is to save space on memory. So saving space on memory can also execute at the end of the day. All the tables data can be in delta. I want to save, I have enough buffer area where I can store. At the end of the day, I perform all these jobs in one shot. But whenever you have large volumes of data that is coming in, we discuss one scenario. When you have 1 GB of data that is coming in, then system immediately perform delta merge. Because system assume that, okay, if lot of high load data are coming, then it may increase the memory. So immediately at that point of time, system performs the delta merge. Is there any backend running on the merge activities? Yes. There are background services that are running on the merge activities. If you go to HANA and then if you want to see the services, you can double click on the instance. Double click on the instance. Once you double click on the instance, here we can see landscape. In the landscape, you can see daemon. There is a process called daemon. A daemon is nothing but a background process. A daemon is a background process or a job that takes care of these delta merge. A daemon internally has hot dog. Hot dog takes care of these merge activities. Daemons are nothing but jobs that execute in the background on the regular intervals of time. So let's go to the next question. So when will auto is performed? Only when we request for data preview? Auto is performed Auto job is performed based on the system resource availability. So system knows when the utilization of the system is high. Now, for example, for a developer, you see here, if I right click on the, now I'll just show on my laptop. I'm just right click on my, and I go to my laptop task manager. This is not the system. So if I see the performance, please see here, in my laptop, my utilization is 7% of the CPU and 3.1 memory out of 15 GB. And mine is so I have a quad core CPU. You have four cores. It's a quad core, and then there are logical 8 processors. Now, what I'm trying to show you here is the utilization is very less now. Please see, utilization is 6%. It's very less for the hardware I have. Now, if I move on to the server, I right click on the server task manager on the client machine. Now I'm on the client machine. I see utilization is 53 to 57%. So it checks for the system resource availability because resource availability may change from time to time. So during this time, it executes this merge activities on how system utilizes at that particular point of time. But most of the time, delta merge is executed on the night and system is not so busy in doing operational activities. So these are the questions in the chat box. So today I did not have opportunity to see calculation views of type cube. So tomorrow on the first hour we will see the calculation views of type cube. In the first we will complete that and move to the next topic. In the next topic I'll just complete that engines diagram we drew on the other day and what engine is exploited. Again we revisit the topic and we can complete. Thank you everyone to attend today's session. So you want materials. So I've been for materials. Okay. Bharat? Mr. Bharat, are you there? Okay, I will let Bharat know this. You require materials. I'll just ask to check. You're Rakesh, right? Okay. I'll ask Bharat to uh, ask why you haven't received materials. I'll ask him. Any issues, please let me know. I will follow up with Bharat. Thank you, everyone. I'll see you tomorrow, same time. Have a good day to everyone. And good night. Thank you.